Hi, it's Gadget UK here again, back for the second part of the 1541 Mark II disk drive. In the previous part we dealt with corrosion on the motherboard, we cleaned up the chassis, you know, the plastic part and stuff, and some of the metal work on the drive. We replaced some capacitors, and we needed to find some solution to the missing lever on the front. So just doing the drive speed check here, I did need to clean the heads after sticking this disc, and actually it wouldn't work. And I've taken a photo, I'll stick that up on the screen here. You can see it was absolutely covered in smeary marks. Those are the marks I was talking about. Even after cleaning with IPA, that's how it looked. I had to use plastics on it again. And then it's good as new, I'll show you that in a minute. But anyway, it's too fast. As you can see there, speed analysis too high. 320 RPM, we want about 310. So I'm just going to adjust that little variable resistor. I'll go, what do you think? I'll go counterclockwise, just a smidge, there we go, done it. Well, let's just see how it comes back. Slowed down a bit, hasn't it? I think current speed 316. Just leave it again. And I'll go slightly more counterclockwise. No, it's gone back up to 320. That's strange. 320. So I'm going to go a fair bit more clockwise. There we go. That sounds faster to me. And I'm going to go the other way. Right, I've gone the other way. There we go, it's too slow now. You can actually hear it. Right, so now it's saying excellent. I need to compare this actually to my other 1541 disk drives, because you know what? I could be putting this out of spec here. 310 satisfactory. It was excellent a minute ago. Why is it now satisfactory? I guess the belt is going to affect that, isn't it? If the belt's, I don't know, not as taut as it should be, it's going to be a bit variable there. Anyway, I think I'm just going to leave it like that, test it like that. We saw what it was originally. It was, no, it's gone too high again. It was 320, wasn't it? There's the thing I'm not sure about, if this software is aimed at an NTSC system, because that could be the problem. 320 might be actually correct on a PAL system here. And that's what you need to adjust the RPM. I've set it back to 320 because it was on 320, and if we compare to one of my other 1541s, I'll bet that that's what it's supposed to report. I think that software is for an NTSC C64, and they run faster, the clock speed runs faster. So I think that's what it is. I think that it's US software. So using the 1541 diagnostics card there from World of Jammy, which I trust a lot more, you can see it's nearly 300 RPM. So this is the thing, had I continued to set the speed using that other software there, we would be out, so I need to increase that slightly, which is clockwise, just marginally, I think. No, it's not, it's anti-clockwise. Yeah, and it's in real time, this is what I really like about this. You can dial this in, just in the same way if you used a frequency counter, or an oscilloscope, and we might do that with the Rigol here in a minute, I don't know. Just trying to get that spot on. It's not far off, is it? It's toggling between 299.9 almost and 300. So you know what, I'm happy with that. That is really nice. Just letting that do a performance test, you can see it's formatted it, the mechanical test's okay, open file for writing, it's written it, it's closed it, it's opening it. I think it scratches it in a minute, it's reading it just now though. Scratch means delete in C64 speak. There we go, it's closed it, it's erasing it, updating the BAM I think. Passed. Fantastic. Now if you use this diagnostics cartridge and you do an alignment check, you need a disc that has been formatted with half tracks written to, because they've got the two columns here. This is where it checks out the half track, you know, it's in between tracks, and it's a bit hit and miss that compared to some of my other drives, certainly here as you can see and right at the start. But that could also be this disc. I'm using the Free Spirit software disc here, you know, it's got the tab there to protect it, so it's not written to, it's just reading it. But nevertheless, that disc is dirty, and I can show you that actually. And it may have dirtied the heads up again. It's kind of ironic that this disk drive alignment software is dirty. You can see some marks there, but that's perhaps from the spindle. But if you look at the disc in the light here, and if I just try and rotate it right at the top there, you can see there's some contaminants. I'm not sure that's going to come out actually. To be fair, I think a lot of the dirt's come off that. I wouldn't be surprised if it's back on the head again. Let's just check the head. And I guess you could see that diagnostics tool there, the cartridge, as a way to clean a disk, actually, because you can do the alignment check and it doesn't care, the drive and the system don't care whether there's an alignment problem or not, whether there's a problem. It just sends the command, step up the disk, step up the disk, step up the disk, and read, etc. So, whereas normally you can't do that. Yeah, that's dirty again. My point being is, because the diagnostics cartridge is sending the commands, telling it which track to step up to, the drive will just obey that, even if it can't read the track, if there's dirt there or whatever. When you try loading a game, that won't happen, will it? It will fail and stick on that track. So what you're doing is using the head to clean the disk. You'll see what I mean here now. And obviously the more times I do this, the cleaner the disk will get, and I'll have to keep cleaning up the heads. Or the head. Yeah, oh, that's a horrible smear. Wait till you see this one. It actually looks like someone, but as you can see, there's like a brown poo on top of the head. So yeah, out comes the plastics and IPA again. So I haven't got the studio lights on the moment, it's a bit dark. As you can see, a score mark of on the plastic here. It's an old piece of plastic from a printer that was smashed beyond repair. I'm just now trying to cut through this, which isn't the easiest thing. It cuts really easy though. It's taken only a few strokes there to get that depth down through that, so it's pretty soft plastic. Yeah, and sometimes thinking outside the box can lead to some reasonable ideas. So I need to file this piece of plastic down a little bit here. It's a bit uneven, but you can see it's mounted here. I removed that screw and put a slightly deeper screw, same thread, it's a metric thread that. Ideally, what you want to do here, and are you watching this, Dennis, or someone like that, the 3D printer? 3D print a piece of plastic that can have, a hole for a mount here, even this mount, because I've got a mount there. I've got a piece of rubber stuck on top of there that will mount perfectly with the lid, just to hold that in position at that point. But the 3D mount could be extended over here and mounted over here, so it could be, a long piece of plastic with some mounts for a servo. It really is that simple. I can't imagine that being rocket science to produce. But if I now power this on, I'll show you. Programmed up the Arduino with a bit of trial and error here, so you can see that it just moved a bit to its default position, and the LED, that's the power LED, the door shut one is not illuminated. If I press the button, just watch, I'll just hold the top of this, closed, yeah, and both LEDs lit there, so we've got an LED. And if I, hang on, let go, just press the button again, it's not easy with one hand, you can see it goes up. And if we shut it again, and then I disconnect the power, just keep an eye on it, it frees up. And if we switch the power back on again, default position, LED off, press the button, LED on to show it's closed, and it's closed. The torque has no issues at all, got that perfect. So I've tested this with the cover on here. This grips the edge of that, and then it's just held by the lid, and it's the perfect height. So actually I think I've solved the problem. So the only remaining questions here are where to put an LED and where to put a button. Now this is the button. I was toying with the idea of putting it through the front here and having the button on the front, but this metal is in the way, and the thread here, the metal part, is too thick to go through that. So I mean, I could drill that and then put the screw it straight in, and it would perhaps just protrude enough to press it there. But I think actually what I'm going to do is use this beefy LED to indicate what that's indicating down there, that it's shut. Stick that through the front here. Hang on, if I can try and do that. Yeah, I'm sorry about wobble cam here. I'm going to have that LED there to indicate whether it's open or closed. And then I think I'm just going to drill a small hole in the back, somewhere maybe here, for that button. That's what I think I'm going to do. You could always revert it, no one's going to notice that hole in the back. You could, reintroduce, and that's the other thing, I removed this with a spring. It just adds some additional torque here that fights against the servo. There's no point in it. If you've not got the bar, as I haven't, there's just no point in this beam here. So on this side here is a split ring, you just remove that, and I've managed to save that, it didn't fly off, and then the bar pulls out, and of course the whole metal arm and the spring comes out. So yeah, I'll report back when I've done the few bits now. And then the final thing obviously is powering this from the 5 volts in here. You can see I had to wedge capacitor in there. Why? Well, this servo with the torque, it's creating some dips in power, Yeah, so it stops the Arduino, and the Arduino resets, and you get in some interesting loops where it moves a bit, and then it resets, and then it moves a bit, it resets, and then it moves all the way, and then it works alright for a few times, and then it resets, etc. So it needs a cap. So I've got like a, I don't know, a 470 or something microfarad, so I need to mount that somewhere properly onto this, and that works reliably. But we need to power this with 5 volts and ground, so it's just a question of, will the Arduino and the servo work without causing issues with the disk drive? I don't know. And then need to tap 5 volts and ground off, and then we need to find somewhere to mount this. So I've got some cardboard at the moment at the back here. I don't have any solution for that. The LED is in place, some 3D printed parts, something for this and something there would be really useful. Anyway, if I press the button, hang on. So it's going down, watch the LED, there we go, locked. Press the button, going back up, LED off. That's cool, isn't it? I think what I'll do is get the LED to illuminate the minute it starts to close, rather than waiting to get to the bottom position like that. Anyway, I need to test it with the lid on and see if it actually works now. The only thing I need to do is just clean up the plastic here. It's a sealed unit, this, it's one of the ones that's potted, weighs a ton, but it works. Yeah, clean up the connector here, so yeah, exactly the same thing. So I'll just have a clean around those pins. Yeah, they're fairly clean there, look, there's a little bit of dirt on there. I'll scrunch it up now though, so that I can get it in between the pins there. Yeah, there's quite a lot of dirt coming off that now. See that? See that on that side? This is the thing, this is why it's worth scrunching it like that. Right, so a bit of beta testing here, switch it on. So you saw a flash there, we heard the servo. Just occasionally, both LEDs will come on because of the inrush, and you just power cycle it, and then it's alright. And what's happening there is the 470 microfarad cap just needs a bit of time to charge up. I guess what I really should do is a revision to this and power the servo separately. When it's just sat there, you can hear it. I'm not sure I can hear it now. It's mostly when it's closed, but I'm going to have to do load star, 8,1 ready. Yeah, that's closed. Let's open it. Alright, let's just close it again. Yeah, so the LED is lit. I'm ready with the command there. Let's just hit return. It's working. Wow, that's so cool. But as I say, there's some issues here. There's the issue with the inrush occasionally, means it needs a reset. And you can reset the C64, that will reset the drive. I'm just typed run. But that looks like that's working, doesn't it? It's taking a while to decompress. So we've got our cracked row, hit space. Should get some instructions or something, I think. Yeah, run stop, space, and then it should be H for high scores, and N to just load. So it should hit the disk again in a sec. High score, load saves. You want to reset? No, we don't. Hitting the drive. Loaded the high scores, fantastic. It works. So let's just hit the open button. That button, it's not a very good button actually. Hey! Hopefully, yeah, we can get the disc out. Fantastic. So obviously, that is not a definitive way of stopping you from wrenching the disc out and, you know, pulling it against the heads. But nevertheless, that seems to work. I'll close it again. Sweet. Right, so I did put a short up on this about a year ago or more. It was Cather's. You want to blame something, blame Cather's A3000. It came at the time when I was working on this, just started working on it, got this prototype working here. You can see I removed the servo for the moment. I've got ideas to stick a switch and a MOSFET, I'm not sure yet. But this is the proto here. Hang on, that orange one's just come off. I think it was D7 actually. Yeah, I'm just going to stick that back on. This is the problem with it. These connections were so fluffy. So testing it, it works, but you knocked it or breathed or something and then it stops working. So the switch here I've got two of those little these things here, these connectors soldered on. It's just really bodgy. So what I'm going to do is, I've got some of these male and female counterparts of different types of connectors here. Those two go together quite nicely. I'm going to put those in place for the switch. I can't detach them now. You know, so I'll cut this quite short and have it coming out, and again have that quite short and have it so you can detach the switch. I need to do a similar thing with power. For the moment I've got this USB power thing going to the motherboard down there into here. I'm not sure I want to use that. I'd rather have another 2-pin connector of some sort. And I've got a few different ones here. I've got some of these ones, male, female, that we've got black plastic here, and I think, yeah, that goes like that. So same sort of thing, they clip together and you can unclip them. So I need one for this, I'm not sure about the servo. I think I'll leave the servo with that connector there for the moment. But yeah, what else have we got? The LED. Yeah, so I'll probably use a couple of those for the LED, maybe, so that the LED is detachable. And that should just leave the servo. Yeah, so at this point here, you can see me fast forwarding through fitting the detachable wires, you know, getting rid of those awful DuPont wires and replacing them with those connectors that I showed you. Now, this all worked well. I didn't show you the actual testing and failure, but one of the servos died. There'll be more about that later. So as you'll see in the next part, I changed my approach to trying to lift the thing instead of trying to push it down. So there's nothing being easy about this at all. It has been a complete bodge. I've now got what's the word, a lift type system, where it's a piece of wire wrapped around the metal there over a screw here, and I've got everything all balanced and it seems to work. And I've removed the tension from here, because this is the point where this here needs a lot of power to lift, and you know, to lift it basically, because of this, to press it down. But if you want to screw those, just so they hold in place to guide it, granted it moves slightly as it goes up and down, but you'll see it should go up to start with. I think it's already up. Press down. And it goes down. Nothing caught there, I don't think. This is moving though, because there's only one screw, so I need to deal with that. But if I move it the other way up, you can see it raises it, and it does kind of go oop, so it kind of moves around. The main thing is this spindle here seats itself properly when it goes down onto the spindle below, and then the carriage here can move freely and flat along this point here. You know, it's down. Yeah, granted it's just gravity holding it down, because the springs here are not pulling it up. It's the best of a bad situation. If I'd had a 3D printer, I would, and I'll send it to Dennis anyway to 3D print, because we might be able to improve it further, but I'd have something that goes all the way from the screw point here to here, just like a little part of a frame that mounts over there, and then it would be held down a lot firmer. And I would also probably use the actual servo to go up and down, and have another micro switch somewhere so that it can detect the micro switch, or some current sensing. But I've shied away from all that stuff. I think it's getting way too complicated when I can achieve it this really simple way here. The key with these servos though, you've got to listen to it when it gets to the end of its travel, because if you can hear it going, or you can see it just moving a little bit, that shows that it's under immense pressure, and the computational stuff inside there is something, maybe the potentiometer, and there must be some sort of little simple MCU that controls it in terms of what angle it's at. Yeah, and because it's on the edge of an angle, it's a bit of force on it when it's trying to hold, and that's what you can hear. You can hear it trying to hold that position. It doesn't do that now. Now we've got this piece of wire pulling the thing up and down, gently lifting it and lowering it. Yeah, it doesn't go quite as high up as it did. I'll show you. If I shut it and then switch it off and on, the way I wrote the firmware for it, when you switch it on, it initialises back to its start position like that. Now it moves blooming quick. What it's not doing though is fighting against the spring here, and it's not going too high as it was previously. So this is now high enough so that you can get the disc out the front without any issue. Anyway, I'm going to test it. I'm just going to see how that is. If that works, I'm going to roll with it for a while, use it for a week or two, test a few new discs I've got as well, and just see how I get on with it. Yeah, so the Arduino stuff here, it's really simple. You've got libraries, and I installed, I think, a library for the servo. I forget exactly which one I used. I did this like 2.5-3 years ago. The bottom line is it's really simple. You include, your servo library. I declared some things here for the button pins and the servo angle and things like that, variables, etc. And then you've got a setup, which is the main thing that runs when it launches the code there.
So I'm attaching the servo pin, putting the LED as an output pin, basically one of the I/O pins there as an output pin for the LED. Putting a pull-up on there as well, which is quite nice. The Arduino is quite nice. It's really simple, dead cheap little devices, like you might pay £4 or £5 or something for a little PCB that does this. And you just connect it with a USB cable to your computer, and this software you can program and push the code to it. Really, really simple to use. So if you've never looked at Arduino stuff before, do take a look at it. And then I've got a few different procedures, functions that I've declared here. Reset the servo. It just literally reads the angle of the servo and sets it to a specific angle. That's what happens when you saw me power on, and it goes up to the top. And then you've got a toggle direction method I've put in here, and it's just you've got a boolean, is it open or closed, depending on which one it is. Depends on which way it moves by whatever angle, and you can obviously have a delay. I put a delay there and experiment with that in between the as it moves, as it starts to move, and just move it 1 degree at a time or something. I think I've got there in either direction. And then I have a main loop that just looks around for the button state, what buttons, is the button pressed or not. It dictates whether you want to toggle direction. Is it open or closed? Open or closed? I can extend that further by adding a little speaker or something, use one of the I/O pins to produce some PCM sound or something. You can have a sample playing it. Is it open? Is it closed? Maybe a tone or something like that. And we could do other things. I was thinking of using one of the I/O pins to control a MOSFET that powers the servo before the servo starts to move. Or when the movement is finished, I could unpower the MOSFET and the servo would be not powered. The problem is with the torque there, the servo would move back on its own. So then I was looking at using a solenoid and having another I/O pin to fire the solenoid into some little receptacle hole to latch the thing or closed. Does that make sense? But it would need 3D printed parts. It's just getting really, really, really complicated.
So a while later, you can see I've managed to manufacture something. This is a prototype. It's got a crack there. I went too close to the edge of this. It's a dowel, isn't it? I think you call it a dowel. Is it a dowel? I can't honestly remember now. It's it's one of these things you get with DIY furniture. It goes in a cavity in one piece of wood, and then another. You usually put glue in, and you usually get extra ones. And I got a couple of these extra. So anyway, I'm going to cut this next piece a bit wider so that there's more on the edge here, because it just splits a bit. And drill a hole through again so that I can get this screw through. The nut is secure on the end so that when you turn it a specific way, it can't come back. The wood can't unscrew. I think I'm going to need to go through slightly further and have a nut on the other side to hold this entirely in place. And then I think I'm going to need a larger nail. So that's going to be the challenge, trying to find a larger nail for the next piece. But if I show you this now, you won't believe it, but well, it's pretty much perfect. It does need slight adjustment. When I stick the nail in the next piece, it needs to be 1 millimeter further to the right. Yeah, so that's what I've learned from this. And if I put that in position there, and I can have another nut on the inside here to hold this at the right place so that it won't go out of position. Yeah, and then obviously I need a knob, which I'll probably use the other half of this for a knob on the front. Yeah, again, maybe held with a nut or something, I don't know. But if I position that in place like that, the end of this here, the metal thread, I'll probably use the grinding pen on the last few threads, so that it just sits into that hole a little bit better. But it does sort of centrally position itself. I'll need a grommet or something here to stop this free play, so that it sits in the centre. Yeah, and then as I turn it, it locks into position, but it needs that extra millimeter on the distance of that screw coming out, sorry, not the screw, the nail, to just push it a bit deeper. I would say maybe more than a millimeter, 1.5 millimeters, because it's not quite as low as it should be. And then when you unscrew it, yeah, it works. Look, it goes up and down. Yeah, I'm not demonstrating that very well, and it locks into position. So yeah, all we're doing here is recreating from a photo. I'll show you the photo. You can see how the plastic piece there holds that little pin outwards. So yeah, I think that just needs a slight adjustment. It might need to go a bit lower as well, rather than being central, because on the original design, I think you could sort of tell it's sort of not just the side, but it's down a little bit, and that gives you the additional height there. So yeah, very pleased. Anyway, I'll report back in a minute. I now need to unscrew that and go and drill another hole in here. A bit further away from the edge. Right, so I drilled a hole here using the track cutter, because it's the same sort of thickness. It's a bit thinner than the thread. And then when I start to get more than halfway through, I use the drill in the centre of the hole, so it had a tiny point here, and then I could use the track cut to go through on the other side. And I learned that from doing the other one, because if you were to go through just with the track cutter, it splays the wood outwards on the outer edge, a bit like when you drill a hole on bricks. You know, you drill from the inside of your house and it goes through nice and okay. You get to the outer cavity, go through to the next brick, and on the outside, as the drill bit goes through, it chips a big piece of the brick off. That's what was happening with that first piece, so I avoided that by, you know, let's say putting a small hole in the centre when I got halfway through, and then drilling through from the other side to join up. And you can see it goes in, it's really tight, and then I need to try and hold this, probably with pliers or something here, just to allow me to, there we go, twist that on. Hopefully it won't split this time, because we're not near the as near to the edge here as we were on that other piece. Plastic obviously better, and again it's one of these things Dennis may be able to 3D print something to replace this entirely. I'm going to go past like that, just so there's enough space. Yeah, you see, look, we got a little piece chip off there, but it's not as bad as it was before, and it feels pretty firm in place there. So let's just tighten up that nut. So there we go. So we've got enough room on the end for a nut if we need one, but I might need to go a bit further afield to have more space. I don't know, but I don't know whether they're going to have a nut on the end. Might not need one. So let's just test that out there and see. Yeah, you see now I need to file some of this off here because it's catching on the metal chassis. I thought that might be an issue, but we're not far off. It's just like half a millimetre, just rounding it off more than anything, and then it'll clear the metal. But it is definitely a bigger piece. It's bigger on both sides, and that was easy to file. I took literally nothing off that. Spent 10 seconds on it, and if you see now, if I get that end point there, it clears the metal here totally. So that's okay. So it's just the key now of getting this bar aligned just right, really. You know, the pin, the nail that's going to come through here. So this is the difficult bit. Let's try and measure up against this and then just get it adjusted slightly so that it's better positioned. Right, I went a slightly different way this time. I stuck the nail on this side to give me more length and to get the extra height on the screw. That seems pretty good. I'm going to grind off the one top thread there on the magnification of the thing there to get it to go into this a little bit better, but when I'll show you this, it's almost perfect here now. I think I might need to do something with the head of that screw, I don't know, if I get that in position there. So I wanted to sit better into this piece of metal here, which is why I'm going to remove the thread, and then if we rotate it, you can see it's almost there. I had it locking a minute ago, but then I pushed the nail slightly further. You can see it's a bit tight. I actually think, yeah, I think the thing I need to do is I need to file this down a bit more and deal with the thread there, and then that should be pretty much perfect. Whether it's going to last or not remains to be seen. But if I send this to Dennis, you know, I'm going to donate this drive to Dennis. I did say that when I was messing around with the servos. Then maybe you can 3D print something to replace this, and we can just size up that, and you'd be able to get a thread like this. Have this piece 3D printed here, maybe, with some sort of metal connection in there. I don't know whether it'd be strong enough. Dennis did say that. And then maybe he can 3D print, just design his own thing for the end. Doesn't need to look like the original one, just something that looks like a nice style to go on the other end. I don't know. And obviously could probably need to chop the end off this and manage to cut it down a little bit. So we're not there yet. I took the grinder to the head of the nail as well, but hang on, hold that in place. You'll see, you can, hang on, rotate it, it locks, and you can rotate it back. And if we lock it, it's the perfect height now. That's going to do it, I think. So I just need to do more on the end of this thing here, just try and seat it better in the end, because I'm not convinced it's sat in there as far as enough as it should go. Yeah, and then another nut here, and something to, you know, like a grommet or something, just try and hold it in the right place. But we're there, I think. Alright, so we've got a circlip there to go back on, and I've got pray to the retro gods that I don't lose this now. Yeah, circlip. You get it over the thing like that. That's it. And then what you've got to try and do is not lose it. Always try and put your finger over it, and press it with something like this in the centre point. Up, you can see what's happening. It's trying to ping straight down. That's it, I think. I think that's on. Let's just rotate and inspect that. Yeah, that's on. And if you're wondering where that was, it's on this pin here that goes through there, because I previously took this off when we were messing around with the servo. But if I show you this now, it's pretty hard to do without a lever. Twist, locks in place, perfect height, twist the other way, releases. The nut here is just holding it from coming out, yeah. What I really need is some thread lock on that. I'll do that in a minute. I'll stick some on that because it's loose, that nut. What I'll probably do is get some on the thread and then screw the thread back, because as it goes into the thread, it sets in the thread, and that'll just stop this nut, you know, so you can't pull it out, you know, because it's seated. The screw is seated into the channel up here, but that seems to work. And obviously the final thing really is to chop off this at the right length. I can put the fronts on. That's going to be quite hard to do this way, isn't it? I think, because, well, you can't reach because of the wire. Yeah, I need to try and position this and size it. It's not going to be blooming easy, this, is it? Work out how much of this I need to remain for whatever I stick on the front. And I think what I'm going to stick on the front is another piece of the dowel, actually. I'm going to have one of these like this. I'll file it and I'll spray it. I may cover it with something because it's got a shape to it, you know, a pattern. And we'll have this lever on the front, which I've just now dropped on the floor, as usual. And I thought I'd show you the mess here. Look at this, it's got wires and Arduinos and servos and drill bits and nails that have been bent. Can you tell that was a proto to try to work out? Problem with that, yeah, try and direct that nail through this hole here, through that hole there, in a straight line. It's impossible. It's impossible. It's got to be multi-part piece thing, you know. And as we scroll around here, just have a look at the carnage. Yeah, and I will just raise you up slightly so you can see all the tool trays and remote controls and bits of plastic. That was another thing I did. When I realised one of the main problems with the servo is the tension this spring here adds, yeah. So it's a piece of metal, yeah, and it's screwed in with 2 screws on the underside of the frame there and 2 screws down there. Now if you unscrewed that, the servo had no problems at all moving that up and down, even with a piece of wire to lift and lower the thing. No problems at all, yeah. Obviously it couldn't press down when you were using a wire, so then I switched back to using the servo to move it up and down. And even when you press down here right to the bottom, so this is totally flat like in that position, up here something was fluffy as a result of not having this spring tension. So at this part, when the head's right down here, it was struggling to read, so I had to put the metal spring thing back on there, and then it started working again. And this is when I gave up with the servo and moved on to the let's just go old school and DIY bodge it, and that is working. As I'm cleaning up here, it's you know, things like this is possible not just because of my patrons and my coffee supporters and everyone on Discord and YouTube memberships and YouTube members, etc. This type of fix is entirely possible because of my dad. It's like, if it wasn't for my dad, me watching him fix things when I was younger, I remember him fixing my brother's skateboard, and it was like broken in two completely, and using bits of wood and screws and nails, he was able to craft, you know, a fix that was reliable. Well, it was, until my brother decided to jump up and down on it with all of his force to see how strong it actually was one day, and he did manage to break it again. My point is, though, my engineering fascination, you know, electronics in general and fixing things, stems back to when I was, I think, 9 or 10. There was one time where my mum, me and my brother, right, I think my brother was badly behaved and my mum got cheesed off with it. So we came home from school one day and all of our stuff had gone. Like, the entire room was empty. It was just like clothes in drawers. All of our toys had gone, books had gone, everything had gone, computers had gone. And I think I was about 9 maybe. And I found this little clockwork car underneath one of the units that my mum had missed. It was like underneath, you know, going underneath something, and it didn't work. And I took it to pieces. I went and got a few things from downstairs, tools at my dad's shed, and I took it to pieces and worked on it. But that, again, was because of my dad. If it wasn't for my father, the influence my father had doing repairs, building things, you know, car maintenance, you know, he's really good at that sort of stuff. And this is where I picked up things like this from. So yeah, that's no credit to anybody else but my father. So thanks a lot, Dad. that's it. Let's test it. Let's actually test it. I'll clean this bench. Right, we're all connected up. Power on the drive. Drive's alright. Switch on the C64. Voltages are alright. There we go. And let's do, hang on, disc, I need a disc now. So I'm going to try Kung Fu Master. That was quite sulky before. Just at the last point I was messing with the servo. Hang on, it's shut now, isn't it? Oh, God. I am such a moron. There we go. Let's get that in there. And I think what I'm going to do is I'm going to repurpose one of those connectors that I wired up, you know, the ones that are detachable. And I'm going to use that switch on the back for the reset. So you can reset the C64 using that switch there. It makes sense. I've put a hole there. Why not do that? But the point I was trying to make there is going to use the 2-pin connector on here so I can detach this. Because if we can detach that, then it allows me now to size it up on the front, doesn't it? The length here, if you see what I mean. Because there's no way of getting this screw through that hole without this being detachable. That's the point, really. So anyway, that's closed. And let's now try and load. I've got a disc test as well. We'll perhaps do that together in a minute. A new one that I picked up a few years back. That is not rotating, that's stopped. Oh, hang on. What? Yeah, so hopefully I haven't damaged anything there. Hopefully I haven't damaged the discs. The thing here was catching, so I've trimmed off about, I don't know, 3 or 4 millimeters off the end of that. Let's just try that again. It was pressing just marginally on the disc, and I wonder if that was like affecting its rotation speed or something. I mean, it sounded like it was rotating alright to me, but nevertheless that was part of the issue. There we go, it's not touching the disc now. Let's just see if that's any different. Push that on. Yeah, that's working. So whether it was the pressure on the disc here causing the RPM to be marginally slower than it should be. I forget whether this is belt driven, you'll know, because you'll remember the earlier part of the video. It's been, for me, it's been 2 years, I think, since I started working on this drive. But having cut down the end of that bit of wood there, I'll show you the piece that I cut off it, just so you can see how much I had to chop off. Yeah, it was that, off the edge, with a saw. And how would you cut something nice and straight like that, equidistant all the way around? You cut like halfway into it nice and straight, and then rotate it a little bit, so you've still got an edge, and cut a bit, rotate it a bit, cut, rotate it a bit, cut. But that's actually working now, so I'm sure that's what it was. So you see activity is the point. If you just had a blue screen there, you know, the basic colour background, you'd be left going, is it working, is it not working, what's it doing? That's often why you see these types of patterns. There we go. Crack tro, should be high score or trainer, I think. Do get a pause there. Hang on. And there. Another pause. And then it should load again when we choose high score. Yeah, we'll do high score, reset scores. Now it should load now. Yay, it works. So I'll cut into this and put the 2-pin connectors on each side so that this can be detached, and then we'll just deal with some sort of knob replacement. And Kung Fu Master loaded as well. It's one of the good 8-bit versions, this. The other ones like CPC, Spectrum, Atari ones and stuff, they're not very good. But this one's not bad. It's second to the NES. I think the NES/Famicom version's really good. Yeah, it's another one of these where I'm flying by the seat of my pants, this video. I disconnected the things and I thought, right, let's join those 2 wires up and down. 1, 2, 3. There's 3 wires. It looks like there's 2. There's 3. Yeah, there's 3 wires, which makes sense because there are actually 2 LEDs on the front. So I've joined a single one up here, chopped the extra wire off, and I've used the opposite genders. So there's no way those would plug together, and that would make sense to anybody who came in here in future. So you can't get them mixed up. So I'm going to get now 2 of the opposite gender for the other side and finish off joining 2. That. Right, and there we go. Bodge complete. I just need to test it out now. So I'm going to do that, I think. Yeah, that's working fine. There's a bit of green ink needs wiping off the front there, and yeah, I didn't finish cleaning the gap there. There's some dirt on the inside of the disc slot. But anyway, it's loading and the LEDs are fine. Run stop, is it? Yay! So I think the next thing I'll do is I'm going to find the reset signal on the C64 motherboard, measure around and continuity test while the serial cable's in, because reset from memory is on one of the serial cables. Back in the day, I used to get a DIN and put a switch into the HUD of the DIN, and you plug it, and then you could plug it into the serial port. I had no other serial port devices, and you could reset the C64. I had that for my C64C I owned at the time. Just a little, you know, it's just one of the plugs. You plug the plug in and it's got a reset button on it. But anyway, if we test to the motherboard or continuity test the reset signal, I can work out where it is and just join from ground and that reset signal to this. And then we'll have a reset button on the back of the drive rather than the hole. And you could argue I should have waited until the mod was complete before deciding to stick that switch there, that button. So I've drilled a hole in here. I'll file this in a minute, try and round it off a bit. But the idea is I'm going to screw it on, yeah, but obviously not there. So I need to now try and hold the front piece perfectly straight up here and kind of just gauge how much thread I need here. And I would say I want to go more than halfway in, so it's going to be somewhere here, I think. If I just hold that along there, yeah, plenty of thread there to go in, and a little gap so that it doesn't catch on the plastic. So, hang on, I can't see that now. I just put a green mark on that. There's nowhere to be seen. Is it because I touched it? Yeah, that's just not visible at all. Let's just do that again. I'm starting to wonder now, did I get on something else? It's like as I hold this flat along there with, hang on, a little gap. Yeah, I want it. Oh, it is there. I can see it. I can see it. Yeah, it's because it was covered by the plastic like that over the edge. So I just need to take this back out. That's another reason why I'm glad I extended these wires, because, well, it'll just give me a bit of flexibility here if I just pull out that gap. So there we go. I can move that out of the way. I could try and saw it in place. I think that's a bad idea. I think I'd put a load of pressure on all these things here. So I'm just going to just gently undo that knot all the way back up to there. I've got some thread lock on those things when we finish it in a minute. Pull that out, lift that out, and I just need to just cut now with my hacksaw here. And I'm going to try and screw the thing on. Yeah, and here we are back on the carpet. Yeah, I don't work from the carpet. And I'm going to just try and score it initially. So you want to go gently forwards and backwards, hold it as straight as you can. Now I've got a Dremel. That would make light work of this, but while it's getting the Dremel out, I can't be bothered. So I think using a hacksaw like this, we should be able to get through it. Now, bear in mind, as you get nearer down, you start cutting into whatever's below it, your carpet or whatever. Right, a few minutes later, I did achieve it. It's a bit pointy uppy here. That might actually help when it goes into the wood, because it'll sort of squish out and stuff and grip the thing. So let's now try and get this together. Yeah, so at this point now I realise I've probably cut too much off look, if you ask me. And then, yeah, the difficulty now is going to be screwing this on. The hole is intentionally really tight. Even though I use the track cutter, I might need to grind this or it might tear. Yeah, I'm going to do that. I'm just going to grind that down. Right, that should be alright, I think. Let's give that a go. God, I've got ringing ears now from the grinding. There we go, fixed with a piece of wood and some nails and screws and things. I think you'd agree, that's not bad. It points straight down pretty much, and it goes straight up, and you can see the mechanism moving there. Long-term reliability, yeah, I've got no idea. A few thousand disc loads and the wood will give way maybe. It's pretty sturdy wood, to be fair. And it's not overly tight either, it's just right. Just like the original one was, because I remember when I worked on Jamie Morgan's drive. I'm tempted to not even colour that, you know. It looks alright. Maybe just get the grinding pen on the edges of this and just round that off a tiny little bit on its edges. Right, I'm going to do that reset mod later. I've just tucked the switch wires under there. I just want to get this thing back together. It's been that long that it's been on the bench, and I need to free up space. It's just a case of black wire of the switch to ground, the red wire to the reset connection somewhere on the board. I did measure around from the top side there. I can't find anything easily exposed, but, well, you could find the reset really easy just by, I think it's pin 9 on the serial connector on the back there. So, yeah, it's just a mod for another day, really. I've kept looking at this drive going, when am I going to finish it? What am I going to do about the servo? Well, you know what? I think you'll agree. It doesn't look bad. I cleaned that off there. It doesn't look bad at all. It's yet another example of if you don't give up and you persist, even though you might end up going on a different road, because I ended up with a different road here. The servo was where I was going. And then I went, I think this is getting far too complicated. And there are far too many issues to overcome. Could I overcome them? Yes, I could. If I had a 3D printer, and please don't send me a 3D printer, if anybody's getting that idea, I don't want a 3D printer. I'd love a 3D printer. If I had a millionaire's mansion with a room dedicated to my 3D printer, in this house here, where I have two cats, and I can't swing a cat, you know, I have boxes and things and stuff everywhere all the time. The last thing I need is a 3D printer. And if you're going to invest in a 3D printer, you really want to invest the time in a 3D printer. So what I mean is learning everything you need to learn about 3D printers. It's got its own specialist, you know, things you need to learn, trial and error, God knows how many 100 attempts at printing things, all the consumables that go with it. And at the time, I don't have the time, it's the bottom line. 3D modelling software can't be that hard to do. I can model some stuff myself and then maybe get someone else to 3D print it, or a company. Anyway, that's come out okay, hasn't it? Let's just clean off that mark on the front. So massive thanks to my dad for giving me, well, obsession with sticking with things and not giving up and trying to think outside of the box, because my thinking of outside the box predates when I got involved in electronics. As I say, that's the thing that made me interested in electronics and interested in repair. But it's one of the key things that I've always been really grateful for, an ability to look at things and try and look at things in a different light. Like, how could I actually make this work? It's not possible. You know, parts broken, parts missing, we haven't got a part, no one's 3D printed it, none for sale. What can I do? Well, I can look at the photos I've taken from when I worked on one of these before and analyse it. And I looked at it and went, I can see what's going on here. It's a pin offset with another pin. As this pin rotates, it moves it down, and I can see, looking at the metal, it goes down a curve on the chassis there. So I was like, well, what can we do? How can we join a big bar? I had the bar. I was like, how can I join a big bar to a pin? And I was like, what about wood? Wood would work. It's pretty sturdy stuff, the stuff I've used. And yeah, problem solved. So pleased. Right, the moment I have been waiting for to test this game, Xenophobe. Picked this up disc only. Something like 2022, I think, so it's been sat around for a few years. And let's be honest, that wood grain would be something LGR would be proud of. I'm tempted to stain it, get some wood stain and stain that knob on the front. You think I'm kidding? Watch this space. Anyway, if we could do load 8,1, see if it works. Yeah, I had to cut the camera there was someone at the door, but we've got a title screen. Let's hit fire. Using the Mega Drive pad here from James over at Retro HQ, you know, the adapter, the Mega Multi. Was it Multi-Mega? I always forget which. Just for space. Yeah, spacebar. So a lot of loading. I don't know whether this game takes advantage of a fast loader if you've got one, you know, Epic's fast load cart, etc. I've got one, but like I say, I've not got it connected just now. Anyway, let's see if the game loads. It's really funny seeing this game And the ZIF64 here with these LEDs, this reminds me of some art that I did when I was at the final year, 6th year, or 5th year, or whatever it is. No, 6th year, because it was 6 years, weren't they? At secondary school. And I remember I'd drawn some xenophobe. I was obsessed with xenophobe. I played at the arcade with my friend Andrew. And I was drawing artwork to the xenophobe, all the little critters and things and aliens and things, and it was quite a nice drawing, and it had the word xenophobe on there, and I had like chips and things and LCD displays with ribbon cables, and it looked very much like this, yeah, the way these cables are. And this is one of the reasons, if you've seen the ZIF64 and you're wondering why I've got these cables extended and not cut down to a minimum where you can't see them, I think it kind of looks cool, doesn't it? It kind of looks I'll spell the word B-O-M-B related. It kind of looks like, you know, something that you want to defuse or something. And yeah, the artwork that I drew was a mix of xenophobe and electronics, because I was doing a lot of electronic stuff, so there were chips and circuit boards and traces and things and displays and wires and things just like that. And it's funny how they come together at the same point when I'm testing this disc. This was a game I didn't own on the C64 at the time. I got it on cassette eventually, but yeah, I had fond memories of the arcade, and I think the first system I played it on after that was the Atari Lynx, actually, and that's just the best version, hands down, but this is a close second, so let's start the game. Yeah, the C64 version is pretty good, but nothing beats the Lynx, and the reason the Lynx version is the best, there's a few extra features on the Lynx. It sounds and looks very arcade like the Lynx version. More colour depth, I think, than this, and the sprites just look better. But you have an ending on the Lynx version as well. You go to the alien homeworld or something, and you fight a queen. It's you know, I think you've got to get there. You've got to go around the 7 or 8 levels 3 times, I think. But none of the other versions, either 8-bit, 16-bit consoles or whatever, unless you get a ported version, none of them have the extra features Lynx brought, and none of them, including the arcade, have the queen to deal with at the end. So yeah, the Lynx is quite unique in that sense, that they added that extra part of functionality and, you know, a boss to deal with at the end of it. Very slow at loading. So select our character. Yeah, it looks really good on the C64. Not only the sound is really good, but it looks cool. Insert side 2. I wasn't expecting that. So let's take the disc out, flip it over. Ah, that's so cool, that knob. Until it breaks. But it's quite easy to turn it. Hit Commodore key. Yeah, the music just started to go quiet there, so I think it's loaded. I'm using the old VIC here, by the way. There'll be a link top right to that video. The original VIC chip. So I forget what it was now. It was something to do with the number of, it was the palette, wasn't it? The palette was slightly different as a result of having slightly less luma or chroma signals. Anyway, so the colours look subtly different on some C64s. That's what it is. It's like you're using an old, you know, you're rolling with an old VIC. Still loading. There we go. Yeah, it has to load each part of the level, I think, from the second side. And from memory, you get different music on a few different levels here. I think it's like 3 or 4 soundtracks. So I've got this music on this level, and then it changes on the next one. They're incredibly hard to kill on this version with just the standard pistol. And it's either sound or music, a bit like the Amiga version. The Amiga version is really good, but I don't know, I've got a soft spot for the C64, if I'm honest. And you can interact with everything on this version. Some versions you can't, you know, like so you can pick up all the things off the floor like that. But there are control panels and things to interact with, as well as lifts. Not every version supports all the little controls and things. They all have lifts, I think. There's even a 2600 version of this. I think I tested out the 7800 version on the video for the 7800. It might be in the flashcard from James, actually. Game drive for the 7800. There'll be a link to that video top right. And since it's a C64 disk drive, and we looked at the one for Jamie Morgan, and I may have mentioned Jamie earlier in this video, there'll be a link down below as well to Jamie's channel. and to that video where you can see the fix that I did to Jamie's drive. Same model as this, as I say. Yeah, so like these things here, hang on, click that. Yeah, you can interact, you can press up to break the glass, and I think the second one sets the self-destruct. There you go, self-destruct. I think you can't cancel it. Yeah, you can't cancel it. So I've just destroyed the ship. Well, at least we get to see the next level. We don't have to complete that one. Let's just see if it does have different music on the next level. I'm pleased this disc works as well though. It's like two amazing things for me personally in this video. We've ended up with a success on the drive in an unexpected way, and I've got a cool game that I really wanted to own. There we go. I think it's loaded the next level. Still loading. Oh, there we go. Yeah, different music. Quite cool. Good use of colour on the C64 as well. And we've got, you know, the slightly higher res mode it's in. It's not in the chunky graphics mode, is it? I don't think, for these parts of the screen here. Yeah, the laser's way better. And as you get a bit further on, can you interact with that screen there? No, you can't. See, on the Lynx you can interact with a lot more. There's more things you can interact with on the Lynx version. And on the Lynx, when you hold down, you lower your gun slightly. Here you don't. You're just firing at the lower level. On the Lynx you can deliberately pull down a bit, you know, as you're firing, and it fires even lower. The idea being that unless you fire at the lowest level, you can't hit the little critters because they're right on the floor. So there are some differences in the controls as well in the Lynx version. On the Lynx version you get jetpack. You don't get that on any of the other versions. I think they had it in the arcade. I'm really, really hoping one day someone gets around to doing a Mr. Core for Xenophobe. It's called a lift. That lift comes down incredibly fast, doesn't it? You've got to go up. There we go. Yeah, you see, I'm not even sure if the Amiga version has different music on different levels. I think you've just got one track that plays all the way through. That's the ray gun. It's interesting on this version as well, you don't actually have the graphic of the weapon you're picking up. You know, L for laser, R for radio, I guess, or radiation, or whatever it is. It's supposed to be a ray gun, that's it, ray gun, I think. But this is probably the best weapon. You can get the little, it's like a gas thing, you know, that fires out plumes of gas, I don't know what you call it. And that's the strongest weapon, but it's got a really short range, so I tend to stick with this on any version of the game. I'm not sure you can deal with those things that pop around the corners either on this version. Festa it's called, isn't it? Festa. No. Oh look, he's caught me. Yeah, if you make contact with him from a certain distance, he can get you. But on certainly on the Lynx, if you stand back there, you can blast him as he peeps around the door. But you can't get him on this version. Well, not with this gun. It's too short range. Maybe the laser would do it. Over the moon. Absolutely over the moon with that. Let's switch that off. And let's open the flap, take our disc out. And that's perfect, isn't it? Nice and central there. So yeah, LGR style knob there. As like I say, I'm tempted to stain that. Should I do it like the same sort of, you know, a light colour? Like a light varnish or dark or oak coloured or what? I think light. It goes with the front, doesn't it? It's almost like the same colour style to the front. You might not even notice that. If someone was walking past in a room with all the stuff set up, you might not notice what that is. Alright, I've got a cotton bud with some IPA. If I just lift this up, can you see that? That wasn't like that before. That Free Spirit software disk has done that. And you can see my point now. The IPA doesn't bring it off, look. We're going to need to use plastics on that. Like, that doesn't look any better, really. There's still these orangey bits here, look. That looks awful. I'd go as far to say that most disk drives, when it comes to cleaning them up, IPA does nothing. All these people that just, you know, let's clean the heads. Yeah, it does nothing. It works really well with optical units like lasers because you don't have things friction rubbed onto them. But on disk drives, you've got to use something like this, because otherwise those marks just don't come off. I've got way too much polish there. Let's just get another cotton bud. I've just realised the head might... Oh, it's not. I was going to say the sponge might be touching the top of the head there. It's not. It's raised up quite a bit. See that now? Yeah, plastic polish for the win. If you can't get Maguire's Plast RX, you could use Novus or any other, suitable plastic polish that's designed for super polishing clear plastics. Playing around that anyway. But you can see now the marks have gone, and if we kind of rotate that in the light, you can see it's nice and shiny and glossy. IPA was having none of it. So I've got the wrist strap on, and we're not on an ASD safe surface. The centre pin on either of these SIO ports is the reset pin that the C64 uses for its reset. And if I just measure around here, I think it's that one. Yeah. The second pin on the top row there, so the VCC's there, next to it is our reset. So I can join a wire from that second pin there, and another one to ground. I'll just tap it over here where the cap is, and have a connector going in there, and that should allow us to reset it, reset the system and the drive by pressing that button. And there we go, joined it from the ground on that cap there to that pin. So if we connect that now, trying the right way around. It doesn't really matter which way around those wires go, by the way, even though I have gone red to red, black to black. It's always a good idea to try and stick with the colour coordination like that. It's just to feed that through there, through that gap. There we go. It's not going to get in the way, is it? I don't think. Just got the drive on its own here, so I've switched it on. If I press that reset button now, watch the LEDs. Yeah, it spins, and we get the green light. That tells me that I'm pretty confident there that it's the reset. And looking at the serial IO pin out, it is the centre pin. It's the centre pin, so can't have gone wrong. Switch the C64 on. Put the lid back on in a sec. Yep, there's our system. So I'm going to press that button on the drive, and it doesn't reset the system. That's interesting. Yeah, I've just googled that because I'm sure it should work. We're going to try it with another board in a minute, a later board, 64C, and I bet it'll work because I had a 64C and that worked. I think that from what I've read, the user port mod or the IEC, the serial port mod, don't always work. The reset pin there doesn't always reset the system depending on how the reset's done on the given board revision. I think it's just this board revision, so I'm not going to worry about it, because at the very worst case, if I get a problem reading a disk, I can just reset the drive and then retry. That's quite nice, the system not rebooting and being able to reset the drive. Anyway, I'm going to, hang on, let's secure that drive back in. It's 4 screws, isn't it? It's just a way of dealing with the hole that I put there, really. There's nothing else you could use that switch for, or the hole for. And then I've also put the spring in here in a little plastic bag just tucked at the back there. Should anybody actually get a replacement part for this, Dennis or whoever, well, it's going to be Dennis, because I am going to send this out to Dennis. I'll drop him a message as this video goes up and say, do you want this drive, because it's yours if you do. And just see what he says, really. And I'll show you next all of the servos and things and other ideas I had when I was looking at the servo possibility. But at least you get some ideas should you want to do something similar. So the rest of the drive was cleaned up already, but I may as well just get some IPA, go over the little marks on the underside. Those aren't going to come off. Maybe with a bit of baking soda you might do. But these black marks on the rubber feet should. I think most of that's just from the benches and things being in here for 2 years, knocking around and being on boxes. Yeah, on top of cardboard. Yeah, most of the marks have cleaned off that. So I use the dry bit. Yeah, so a little bit scratched up and marked up on the top, but I think you'll agree it's not come out too bad at all. Let's just have a wipe over there. Yeah, just playing a bit of Operation Wolf here. Yeah, I've got quite a lot of servos to do something with here, I don't know. Expect a servo project coming this way soon. I always found the C64 version more forgiving than maybe some of the others, but quite hard to hit things. You know, it's like you feel like you're firing about 20 rounds of bullets to kill one soldier. Sometimes if you get the cursor bang in the middle of the body, it's not too bad, but it can be quite hard trying to quickly move from one place to another and accurately hit them. The light gun is quite good, using the same adapter from James here. Works really well with the Master System adapter. Master System light gun, those. Shame I can't fire grenades on the second button. How many can you have on a thing? Oh, I like that. There we go. Finished that round quick. Yeah, no speech. I'm sure there is speech at various points, but it's certainly light on the speech for the start of the game. So a quick look here at the bits that were left over. These are little MOSFETs on a little adapter, you know, so you can provide power and some connections, and it can switch off and on the power. So in other words, you could run a motor, and that was the idea, to run the power for one of the servos through this and have one of the I/O pins connected to this, so that when a micro switch is pressed, it could disengage the power to here for the servo, so that the servo is then no longer driven. The problem is, I experimented cutting the power, as you saw in the original series there, and as soon as you switch the power off when the servo is down, holding it down, it goes, comes up. Yeah, the spring was, you know, moving the thing. So when the power's not engaged, it wouldn't stay down. As soon as you release the power, it went like that, and it moved against it. So in other words, there was constant movement by the servo under power. It needed the power, and that's the problem. Now, hang on, there's some packets here that have just got like the cardboard from the top, but I've got a bunch of different ones here. That's the 2G one. That's what I started with, I think. And the 2 weedy, and I had a few of those. One of those is in pieces here somewhere. In fact, the gears are in there. Can you see that? Yeah. That one's a bigger one, I think. I can't read what that says. Is it 6G? Or, hang on, there's something stuck to it. I think I may have stuck something to it, a sticky foot. I'll pull that off in a minute. That's the broken one. That's the broken one. Because it's not got the white bit there. I took that to pieces. So, yeah, so I had those 2 servos. And then I got one of these, a 6G one. Another 6G one. I think I ordered some and then they didn't turn up, and then Salah originally said they'd sent them and they didn't arrive, and then they sent me another one, and then it did arrive, and I said, oh, it's arrived, I'll send you the money. So it's alright, it's alright, it's been a week delayed or something, just keep it. So I ended up with 2 6G ones there, and then I got an 8G one as well, same as the one we ended up trying, I think. And then some little connectors here for the, you know, the servo connections, 3-pin connections, and then of course our Arduino with the bit spodged onto it, our LED, which I can put back in my LED drawer because we just ended up not using it. And there we go, there's the last one I used, the 8G. And that was strong enough. I reckon I could have just left that there, and under it, the tension of it going, holding it down, I reckon it would have been alright. But I didn't want to risk it, and you can see the bodgy bit of plastic which broke in two, which was cut and shaved and filed and all that sort of stuff. And my dodgy DIY clamp to hold it in place with one little bracket, you know, formed out of a right angle of plastic there myself. Holes drilled, stupid size screws put in place. So, yeah, I'll take that servo off that, because I'm not going to do anything else with it. And I can put it back into one of these bags, I guess, with all these parts. The Arduino I will use for something else that will feature in another project. And before I forget, let's put that down. There was also these. I got these as well. This was going to be another part of the a potential solution. So it's a little electromagnet. Yeah, 2 connections go into this little metal thing here. Again, you can drive it from the Arduino. And you probably need a MOSFET to power it, to be honest, because it's going to draw a fair bit of current. But and the Mark 3 volts these, so you just feed 3 volts in there, and the pin you stick in there, and the pin shoots out. Yeah, and then you switch off the power, and it springs back. So the idea was to try and use the servo to move the the thing down, and then shoot a pin out to hold it, and then I can switch the servo off, and it's not got problems with the servo. But then what you then need to do is move it back down with the servo and then pull the pin back out. So I could have done that, but again, you need some way of mounting it. There's no screw fittings or anything on this. I'd need something 3D printed to be designed to fit this in, and a micro switch, you know, and something to hold the servo, etc. It's just far too complicated versus the caveman style woodwork that we did. And something else I just remembered, the other concern I had with something like this is when you're driving a motor, you're going to have magnetic fields generated in here. So, you know, the proximity of where it was on top of a metal plate. It could magnetise that plate, which in turn could affect discs. But I don't think it was strong enough. I think it's such a weak device, even though it's got very strong torque, you know, high G. I don't think that would have caused an issue, but that's the sort of thing to think about. So when you're sticking motors in things, you need to think careful about where you position them and the magnetic field that may be generated by something like that. And incidentally, in terms of working out the G rating here, I could have been a bit more scientific. I could have got one of those little pressure gauges you can get, you know, depending on, you stick it on a surface and you push it down, and depending on how hard you press it, there's a little bar moves and you can reset that each time you do it, you know, each time you test something. And I could have in theory pressed that bar, the metal bar, down until it's almost flat and just hold it and just see what it was set at on the G rating. And if it's not in G's, it might be in Newton meters or something. You can, you know, you can cross calculate using formulas to work out how many G, assuming that's what that means there, 8G. Yeah, to work out how much pressure would be needed to hold, you know, to move it. But it's the holding that's the problem. Moving it wasn't an issue, it's holding it. Because if you listen to this really close, you could hear the motor going. It wasn't moving, you couldn't see any movement, but you could hear those noises. And I think that's why the other one just dissolved, you know, the gears in it just dissolved, because internally the gears are going left, right, left, right, left, right, left, right, high frequency. Well, you leave it like that for 20 minutes while you play a game and see what happens. You get friction on those teeth, they warm up, and eventually one of them just dissolves. It's more than they're actually, you know, normally rated. Even with the G rating, they don't usually have that kind of thing, do they? They're in a radio controlled car or a helicopter where you're steering one way and then you're steering another way, and the kind of resistance you get is just from the occasional bump maybe on the device from shocks and things. You'd hope shock absorbers and things would take care of that sort of thing, but certainly in any flying or water vehicles you wouldn't have any resistance on those gears generally. Apart from maybe where you got high G turns maybe, but in something like this where you're trying to hold something constantly with a certain amount of pressure, well, yeah, it's not going to hold up. It's not going to hold up. You need to pin it or do something to stop the power to the servo, you know, latch it. Because I thought about that as well. I thought about moving it down onto some sort of fitting where it latches and then the servo can go back up and it stays latched down. It's just a complication, isn't it? How would you latch something like that? On a C64C, same problem. I press that reset button on the drive. It doesn't reset it. Hang on, I haven't got the keyboard connected, but anyway, trust me, it doesn't reset it. It resets the drive, but not the C64. I am sure that mod works on some systems. You know what I'm going to do? I'm going to connect to VIC-20 up, because I'm darn sure it works on blooming VIC-20. Right, power that. Right, I've got video, press reset. Yeah, that reset the VIC. So I'm not imagining things, it is about board revision. I think some of the older C64s, just like this VIC-20, will reset. Watch the cursor. See it stop flashing and then the screen went like that. It's reset. 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 So it does work, just not on all C64s. But does anybody really care? No. Which takes us to the end of the video. So it's been about 2.5 years in the making, but yeah, I think you'll agree it looks alright and it works really well. Yeah, and it's not too stiff there, so that's really cool. It looks great. There's literally hardly a mark on this drive. I cleaned up the power supply. You saw me clean up that was absolutely filthy, and everything just works solid. The only thing I don't have to send you, Dennis, is a cable, a serial cable. They're only about £4 or £5. So if you want this, obviously just let me know. I'll send you a message in Discord now. It's yours if you want it. Originally it was going to be to try and 3D print some mounts for servos and things, but as I say, the complication with that is, well, all the stuff that you saw a few minutes ago. It's MOSFETs and micro switches and what's his name, you know, for solenoid, a pin, something for a thing to go in a hole and all that, and it's just like, and then obviously just a little bit of time to do the Arduino code there. It's not hard to do that, but the hard part is the engineering part of engineering those 3D printed plastic and designing things so that things are in the right place. But Dennis could develop something for this. You know, that thread, you can buy those threads. I don't know what size it is. I just one I had knocking around. It's just a single piece of threaded screw without, you know, a thing on the end. That's all it is, a piece of thread. So you could get one of those, and Dennis could maybe design something to be 3D printed in resin or something that would go on the, you know, the side there with the bar coming out of it. And a nail could be used, or a pin or something, and a new knob could be 3D printed for this. I don't know. So anyway, it's yours if you want it, Dennis. I do hope you found that interesting, and I share the evolution here despite the fact we didn't end up with what I thought we were going to end up with, just to show you, you know, determination and persistence and looking at things and thinking outside the box, you know, thanks Dad, can lead to a solution. Yeah, determination is the key, really. When you're determined to do something, you'll do it. Anyway, I hope you found that interesting. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. I'm sorry on the delay on this video. I've just got kidney problems at the moment for the first time in my life that I've been made aware of, and I felt terrible, and it's just been incredibly hard the last month or so. So anyway, I'll catch you in the next video.